this part of the lesson, we will talk about that is known as the free body diagram, or FBD. What is free body diagram and how can we draw one of them for a given situation? So now, when we have a situation, and I will just start with a simple one. When we have a situation, an object that is at the surface of the horizontal surface, an object that has a mass m that is at the horizontal surface. This in physics is known as the situational diagram. So it's kind of describing what the situation is. But in physics, we don't work with always the situational diagram. We have it as a middle step between the English part of the problem and the free body diagram. Because what do we do in that free body diagram? We draw a diagram that is free of the body. It's saying it's free of the object. Now, we have to have the object because we said that forces exist when we have an object, we are experienced on an object. We have to have an object. The substitute for the object that is here will be a dot. So this dot here, where everything will start in the free body diagram, is representing the object. When you go to higher level of physics, you will see that this dot is the center of the mass of the object, is a point on the object that all the mass of the object is accumulated. So it's a dot that has the whole mass of the object on it. Anyway, and then we can either draw a circle, and for initially you may start doing this, and then see what are the forces that this object is experiencing. But the key on the free body diagram is that all the forces will start at the object, at the dot that represents the object. So always start with the universal forces. And in physics 20, what you will see as the universal force is the force of gravity. So the force of gravity, we said that is a force that goes toward the center of the earth. So starting from the object, going toward the center of the earth is force of gravity. We said that the magnitude of this force is mass times acceleration due to gravity. So now, do we have any other forces? So after you deal with those that are known as the universal forces, you ask yourself, do I have any other forces? Do I have a force applied, first of all? No. Do I have a force of tension? No. Do I have a spring? No. Do I have an object that is on a surface on the situational diagram? Yes, I do. Therefore, I will have a force normal, okay? Force normal. And force normal is a force that is perpendicular to the surface. So if this is the surface, perpendicular to the surface will be force normal. Now, do I have a force of friction? Maybe. I don't know. I didn't mention anything about that. So I will leave it out for now because the object is a stationary object. And even if we have a force of friction, we will not kind of see it. Let's take another situation. Let's complicate this situation a bit. And now, again, in a horizontal surface, we will have an object that is in a It's again, it's stationary, and it's experiencing a force applied that is horizontal, parallel with a horizontal of 20 newtons. I will just put a number there. Now, the object again has a given mass. Doesn't really matter what is the mass for now. So again, what we will do is we will convert this situational diagram into a free body diagram. So we'll take the object of interest, which is the object with mass m, and we'll replace it with a dot that is representing the object. We'll start with the universal forces. The universal force is force of gravity. Force of gravity. On physics 20, this is what you will know as the universal force, force of gravity. And then again, since the object is on a surface, then we will have a force normal that is perpendicular to the surface. Perpendicular again means 90 degrees. And now we have a force applied. The mistake, not the mistake, but yeah, the common sense for that students do is they take this force and then they say, here you go, force applied, 20 newtons. But the rule for the free body diagram is to have all the forces starting at the object. So this will be wrong. Ooh, this will be wrong. And the force applied will be starting at the object and going on the direction that you see on the situational diagram, the correct one. This force being here is not the correct one because it is ending, the force apply, it's ending at the object. The rule for the free body diagram is everything starts at the object. Clear? No? Let's suppose that we have an incline. And on the incline, we have an object with given mass m. Okay, so let's suppose that the object is moving on this direction of motion. And we do have a force of friction. So the object is experiencing a force of friction. So now let's start by drawing the free body diagram. So we'll start with replacing the object of interest, which is the object with mass m, with a dot. And then we start with the universal force of gravity. So force of gravity, even though that we are in an incline on this situation, still it is starting from the object going toward the center of the earth. And then the object is on a surface, the surface of the incline is something like this. Therefore, we will have a force normal, and the condition or what we said about force normal is perpendicular to the surface. So it is starting from the object perpendicular to the surface. This is force normal, okay? So we'll talk about this. And now, since the object is moving and we have a force of friction, because I said so as a given to your problem, then you will have a force of friction, and the direction of the force of friction is against the motion. So if the motion is going down, then force of friction will be going up the incline. Force of friction. Does it make sense? Let's take another situation with a horizontal surface. So let's suppose that you have a horizontal surface that an object is on it. An object with mass m is on it. And then you have here force of friction. So you have friction between the surfaces. And you have a force applied that goes like this. A force applied that is with an angle of, let's say, 25 degrees. And the magnitude of force applied is 20 newtons. So now when we are drawing the free body diagram, we'll replace the object of interest with a dot. Okay, this dot is representing this object here that is on the surface. This is what we are interested on. We have to add here that the direction of the motion is, let's say, going east. So then we start with universal force, that is the force of gravity, that is always starting from the object going down toward the center of the earth. And then since we have an object that is on the surface, this is the line that represents the surface, then we will have perpendicular to the surface, we will have a force normal. Perpendicular again means 90 degrees. Since we have the force of friction is always opposing the motion. The direction of the motion is east. Force of friction will be opposite of east is west. Opposite of down is up. Doesn't matter what it is. And then last we have the force applied, that is something like this. Force applied given as 20 newtons at 25 degrees with the horizontal. Is this clear? So let's suppose now that we have an incline again, and we have an object that is stationary, object with a given mass, stationary, and a force that is applied to the object, parallel with the surface. So now the free body diagram, we take the object of interest, which is the object with mass m, and we replace it with a dot. From here, notice here, guys, how I draw the force of gravity, because what I have seen is drawing force of gravity like this. Okay, forget about it. It's not that the force of gravity. Okay, force of gravity, the definition of force of gravity is it is equal to mass times acceleration due to gravity and going toward the center of the object. You have a surface that is like this, and we incline. So this line is representing the surface. And then you have force normal that is perpendicular to the surface. Okay. Perpendicular to the surface. And then you have a force applied that is going up along the surface. Now, the mistake that the students do is they draw the force applied like here. No, don't draw it here. Force applied, or on the free body diagram, everything starts at the object. So you take the force and then you move it with the starting point at the object. And since we don't have an object that is moving, then those are the only forces that the object is experiencing. But if we take the incline and now we add that the object is moving and is experiencing a friction. So we have an object that is on the incline and it has a mass m. We have a force applied that is, again, parallel to the surface of the incline. And as a result of this force, the object is moving direction of motion, is moving up the incline. The free body diagram will be something like this. We have the object of our interest that is represented by a dot. We have force of gravity that is always going down to the surface of the earth. The surface that is represented is something like this. And then we have force normal that is perpendicular to the surface, 90 degrees to the surface. We have force applied that is starting from the object, going up. And now, since the object is moving up, force of friction is against the motion, which means that is going down. Force of friction is, but it is along the surface, not going down in the same way as the force of gravity. Does this make sense? Let's see now a situation when we have an object that is tied with a string and is at rest. An object with mass m. Let's draw the free body diagram of this situational diagram. So we'll start with the object of our interest. This one here. This object here has a mass. Since it has a mass, and always will have a mass, it is experiencing a force of gravity that is going toward the center of the earth, starting from the object going to the center of the earth. Do we have a force normal on this situation? Answers on the chart. No, we do not have a force normal. Force normal exists and is experienced by the object only when the object is on a surface. If it is not on a surface, then we do not have a force normal. The only force that we have here is the tension force, the tension of the string. And as we said, in terms of the tension, is a force. Tension force is a force that starts at the object and goes along the string. And since the string is up, then tension will be up as well. And those are the only two forces that the object is experiencing. Now let's have, is this clear, guys? Let's have a situation like this when the object with mass m is hanged with two strings. Throw them. Two strings. String 1 and string 2. And the object has a given mass. So, and it is not moving. It's in equilibrium. Now, the object of interest is the object with mass m. So we start drawing the free body diagram by replacing the object with a dot. And then we start always with the universal force, that is force of gravity. It's always going down toward the center of the earth. And then we have two strings, string 1 and string 2. Therefore, those will be replaced in the free body diagram with two tension. Tension 1 that starts from the object and goes along the string, and tension 2 that starts from the object and goes along string 2. So we assign them 1 and 2 to to identify that we are talking about tension 1 and tension 2. And again, there is no force normal here because there is not, the object is not on the surface. The object is hanged into those two strings. Clear?